being back here at Explore DDD is really, really nice because it's like being with friends, new and old ones, and I hope you all have a really great time. I'm here to share some insight from event sourcing in action. And my name is Anita Kvamme. I'm working in an energy solution company in Norway, where I come from. And there I'm actually, the company name is Equinor, I should say that. And there I'm actually allowed to do domain-driven design, DDD, together with behavior-driven development, BDD, to build event source business application. And I've been working with software design since the mid-90s. That's a very long time, but I don't know if it hardly has been ever more fun than it is now. So to borrow a phrase from Scott Hanselman, I'm living my dream, at least my work-life dream, building these event source applications. And I wonder, is any one of you living your work-life dream, building event source applications? Some. Anyone building event source application, living your nightmare? No hands on that, that's good. Okay, I have promised you to share some insights from, no, the clicker isn't working. It was, okay, I will use it here. From real project, and I will give you that, but since I'm not allowed to do share all the details from the business, I have made a dummy application just to share my experience. And this application has 2 bonnet contexts, and it has some aggregates. But when we built the real applications, we had some drivers. My company wants to be data-driven, as a lot of company does these days, and digitalization and automation is high on our agenda. We also want to build modular solution, and we utilize external services, which means that we actually need to understand the challenges with distributed solutions. So back to this automation wall. It's all about user can set up some digital strategies, and then they can do this by running algos on third-party platforms that really run algos that buy and sell stuff. So it has to be correct. And we had 2 different bonnet contexts. The one bonnet context has 3 aggregates. One is the strategy for starting and stopping, and it's 2 aggregates for different business areas. And in the algo handler, it's all about starting and stopping and getting the feedback from those algos. But I should start with, what is event sourcing? And in the core of it, it's all about how you store your data. So here we store the application state as a stream of events in an append-only log. But for me, event sourcing is a package deal, because storing the data this way actually influence how I think around domain modeling and how we work when we display the state. And it also helps us with build these distributed applications. So I want to introduce you for 4 building blocks that I pick up from a talk by Sebastian von Conrad. And the reason why I want to emphasize these building blocks is because it's a really good way to setting the scenes when I share my experience. But I also hope, if you are new to event sourcing, that it will help you to demystify how we are building our solutions. The first building block is writing with command. So here you have a user doing something in an application, and that intention is captured in a command, and that command have to do something to something, and that something, that's the aggregate. And the result of this will always be 0, 1 or more events, and when you apply that events to the aggregate state, well, then you get an updated aggregate state. And the initial aggregate state that the command do something to, we get that from sourcing, hence event sourcing, by running through all the events in the stream that was there before to build up this aggregate state. And this building block is deterministic. The next one is reading by queries, or read models as I will call it, because that's what we call it in our team, and it's more the same as we do for event storming. So here you have an event, and you have a read model, and you project, so you pick up the information from the event, and you get an updated read model state. And the third building block is what Sebastian von Conrad says is the cool one, and I tend to agree with him. I also think this is the coolest one. You can say that with writing with command handles client reads, read models handles, writing with command handles client commands, read models handles client reads, well, then the reactors take care of the rest and take care of all these rules. Whenever this happens, that should happen. And it's only building blocks where we actually do any side effects. And a reactor can do both of those things or only one of those. And the last building block is just the event store, where we store the event stream. And for us, we use Cosmos DB, but it's not important what store you use, but you have to have a place to store your event stream. And the thinking here is actually that these building blocks is like Lego bricks, so you can assemble them together to get your application. And that's the mindset we have when we build these applications. And I have been doing domain modeling before I started to build event source application, because I'm doing DDD. And when we do domain modeling, we try to utilize the concept from the domain to build the concept in our code. So a domain model is an abstraction, as all models are. It should be useful for the problem to solve, and that is really important in the cases where you have multiple models, and you will always have that, and you should pick one. And it needs to use the domain language. You should reflect the domain, both the concept and the behavior from the business. And important, it should be exploited in code. Those concepts should be in the code, just not on your PowerPoint. And then it will evolve as all domain models do, all models and all code does. And to get this, of course, collaboration, both with the business and inside our team, is the clue. I will not have time to go into this, but I have to say that event storming for us is the perfect start. And where we actually spend the most time is on this design level event storming inside in our team. We lay out all the command, all the events, and we put the reactors in there. And this is such a great way to have a common visual view when we are discussing in our team. Really useful for us. I think when you understood the problem to solve, you need to know where to solve it. And here I think my toolbox is better when doing event source applications, because I can think different building blocks take care of different types of business rules. So we have the write side and the read side. And writing with command, it takes care of validation for us, the user. Only the user has created a strategy is allowed to actually start it. That's a validation on invariance. Maybe they are only allowed to run 3 strategies at a given time. The reactors, well, that takes care of the validation and invariance too. But in addition, it takes care of all these automation rules, like whenever this happens, that should happen. And it are responsible for triggering the side effect, like handling API calls and that stuff. Read models, I think it's easy to think read models, that's just to get the information there. So there's no really business model or business rules here. For us, that isn't the case. We have some dashboard with a lot of business rules. Let's think that you should calculate the average of the estimated cost per person in the canteen. It can be a lot of business rules related to that, and that you can put into your read models. So when we have figured out what should we solve here and where should we solve it, it's time for the fun thing. And what is the fun thing? Doing DDD? Anyone? Domain modeling. And for the aggregate, it only needs to take into account the right side business rules. And I find that so great. And the reason for it is that I have been struggling in the past to get my aggregates when you have some need on the read side and you have completely other needs on the right side, and you need them to fit together. It's just like in my marriage, when we need to take my needs into account and my husband's needs into account, it's sometimes hard to get the perfect solution. What if we could only think about my needs? And for my aggregates, there is where I am now. I only need to think about the right side business rules, and that makes the modeling much easier because it's actually solving an easier problem. And then you have the domain event. And I say domain event because my DDD heart is with me when I do event sourcing, So we don't put a lot of technical events in our stream. It should be something that has happened and that the business cares about. And here I have a goal with architecting the solution that I call architecting for tomorrow's questions. Because in a data-driven company, someone will, and someone should, tomorrow or the day after, ask a new question that you need to answer based on the data you have. So to achieve this, we need to have all the details into our domain model, our domain events. And before I started to do event sourcing, of course, I investigate a lot. And I heard someone say, oh, you should put primitives in your events because then they are easier to change. But I was like, primitives? It's a domain event, something the business cares about? No, that isn't possible. So we have domain concept into our domain events. So that's our strategy. And then you have the read models. And as I said, there could be quite a lot of calculation. So you need to model that as part of your domain. But we also do backend for frontend, so the things that you actually show to the users. Here we need to use our UX toolbox in order to understand the user needs. And that is what guiding us when we are doing domain modeling related to the read side. In addition to more traditional domain modeling, when we are actually making a model fit for the calculation it should calculate. So I think domain modeling is easier because you have all these pieces and they are easier each one of those. But then, of course, they need to be together in a bounded context. And the really hard part, naming, has all of a sudden become even more hard because you have all these that needs to play together. And in the one of our first applications, we were so focusing that the aggregates to be useful and simple, but all our domain events should include all those details. So we ended out with a strategy configuration and a strategy configuration details concept. But that wasn't such a good idea because this was actually the same concept. It's just the aggregate using a subset of the properties. So for those cases, we now have started to share the concept. But it will, of course, be a lot of concept in your aggregate that is not part of your domain event and the other way around. When it comes to the read models, where here we favor the read model independency over sharing the concept. And to be fair, it's really not often we want to show them exactly what we have on the right side anyway. For instance, for this strategy configuration, we show that to the user, but it's together with is the strategy start or stopped, has it had any issues during the day, and so on. So it's more a strategy summary. And to be honest, naming is hard, and we have a lot of summaries in our read models naming. And I don't think that is the complete optimal solution, but it's the best we have come up with. So we have to kind of live with it, but maybe one of you have a better solution, and let me know in the break. I'm here to learn too. So shaping the domain model, it is easier, I would say, than in a non-event source application. But it's easier. I didn't say it was easy. So we in our team need a friend to help us to shape and reshape our domain model. And this friend is behavior-driven development, or BDD. Or sometimes we call them spec flow test or feature test. I guess good friends has a lot of names and nicknames. And what I have done this before too, before I started to build event source application. And what I really like about it is that you can pick one requirement and you start to write these really simple scenarios on this given when then format. And then you put that into code so you shape your domain model, and then you pick the next requirement or refine the first one, and you reshape your domain model. So it's really an iterative process. And the given, well, that is setting the scene. What have happened up till now? And again, event sourcing. What have happened? It's just a stream of events. So given is always this description of the events that have happened. When is the easy part? Because it's when running the command or when projecting the event, if it's a real model. And then is testing on the result. So let's look at an example. And this is a really simple one, but the truth is that we try to start out this simple if we start in a new area, just to flesh out the concept on a high level first. So you given, we have the domain event and the information there. In addition, the information that is needed for the command. So this is the mocking part of our test. When is running the command, as I said, and then it's all about testing that you get the result that you actually expect. And this result is the new domain events. And since those is the only one we say, we could have actually stopped here and we would got a good automatically test support. And I really appreciate test support. Having a background from some huge monolith application with no automatically testing, I know the value of it. But it is enough for me because I want my BDD test to shape my domain model. We also need to add the aggregate stage here because it should help us to model our aggregates. And that is what we are doing. And then we can have a discussion around these concepts and we put it into our code. And you can say, yeah, that's good, but you said that the domain model should have both behavior and the state. So where is the behavior? Well, indirectly, these tests help us with that too, because that's actually what you need to have as functionality to go from the given to the then. So it helps us to shape. Yeah, this summarizes how we do the right-side business rules with this test. And of course, we also, we also wanted to do this for the reactors. So we started out with this, whenever this happened, then that should happen. So we mocked our domain event, and then we tested that we got the right command. And then we took the next step. So we needed to mock that command again and test that we actually got the correct domain event. But that was a lot of mocking and felt like a lot of work. So we said, can't we test more in one go? Do we need all this mocking? It doesn't helps us. And to make a long story for us, shorter here today, our final scope is that we test everything that is inside one bonded context. So to be honest, that is always what we did in the past. So here I think the focusing on the building block kind of tripped us off a bit. But now I think we are in a good place, so we have this scope, and that can include a set of reactors. But we don't want our scenarios to be big, even though we do this. So one scenario is a typical focusing on one aggregate and the events of that, and then we can have more scenarios instead. That is easier to get them descriptive. Yeah, and we also do some unit testing in addition to this test, but I really like the BDD part related to the domain modeling. And then we also do the same for the read models, and the good part here again, even though the building blocks say it's an initial read model state, well, that initial state can be described of all the events that was used to build up that state. So again, the given is all about this domain event, and then you project the domain event, and you test on the result of the read model, the new state. So to summarize, when shaping the domain model, BDD is useful as it always has been. I actually recommend anyone doing event sourcing to look into it because these building blocks, both the read models and the writing with commands, are deterministic, and it's a really good fit for this kind of testing. Okay, enough about testing. Let's talk a bit more about the cool building blocks, the reactors. Here you have a scenario where you have a writing with command and a reactor. And since the reactor in this case do not do any side effects, it is really similar. It's just the way the command is triggered. But still we need to pay attention to some parts that are different. One thing is the error handling. Error handling for writing with command, that's the easy part because we can throw it out to the user. And we try to make those errors descriptive and not put out the call stack there as we saw in the keynote. But at least we can throw it to the user and they can catch it and do the corrective actions. But what about errors in the reactor? Who should catch those? What we try to do here is also something I think they actually talked about in the keynote. We try to model those as domain event to make those error situations based on a business rule. For instance, if you fail to start an algo as a domain event, a core part of our domain model. And as an architect, I love that because it buys me option. We can start out small, just use it in a read model, in a way indirectly throwing it back to the users, or we can do it Much more, we can have a reactor trying to fix the issue and do corrective action. So it buys us option where we can start small. But what if you get this null pointer exception, the errors that it's not supposed to happen? Then we actually throw the errors. And this is the scariest thing we do in our application. For what will happen when the functionality that push out these events to the reactor, we just push out the same event. And if we have a bug in our code, I'm sure you don't put bugs in your code, but guess what? It happened to us. So it will get in a loop of throwing errors. So we get stuck there. So why do we do it? We know that we will get stuck. Where actually we can't just skip one event in the sequence of reacting to it and believe that the next event it will work. Because those events in the sequence stream is telling a story here. And we are afraid that the next event might be that it's okay, but the next after that we fail because of the first, and we put ourselves in a corner where we are not able to recover from. And that's why we are taking this strategy. We could have put much more energy into this, just skipping the events for the same stream, for the same aggregate, and so on. But this is not supposed to ever happen. And we have a lot of user stories waiting for us to put real value to the users. So this is the strategy we have taken. It has happened twice. And it only takes down the part of the solution that is relevant for the one reactor. So it doesn't take down the whole solution. And we have been able to fix it fast because, of course, we log these errors, so they pop up in the monitors for us in IT. And when we fix it, since we don't have any data issue, we don't need to fix the data, so it's really fast to get everything up and going again. But it's scary. Then we need to handle duplicates, because the things that are pushing out those events to the reactor has at least once delivery, and that is really a typical thing to have. The interesting part, I think, is that this is really technical thingy, at least once delivery, but how do we try to solve it? We are thinking about the business. So we know that, okay, if we have already a food plan algo-enabled event for the last start of the strategy, we deem it to be a duplicate when the same command appear again, and we don't make a new event. So you have to understand the business in order to do this. But I think error handling and duplicate handling, it isn't really hard to do, but it's important that you actually are doing it. And we can put in our test, we can just say projecting the command once or twice, and we actually get test support for that. That's pretty neat. But there are some hard things about these reactors, and I think that is because those reactors actually help us to do some of the hard stuff of building distributed application. It's not special for event sourcing. And that is when you want to call an API, and you also want to save your domain event. Because then you get this dual write, or the true write challenge that someone calls it, because you want to do this in one transaction, and of course you don't have a transaction boundaries here. But the reactors are great because they give us alternatives. And we in our team have discussed a lot because we didn't know how to do this. We knew it was an important challenge to think about and handle, but what is the best option? One of the options we have is just to do the side effect and not save the event, and you avoid the dual write. The drawback, of course, is that your aggregate then don't have a domain event that tells the story of what you have actually done when you call that API. The second one alternative is to have one event and two reactors listening to it. And one can do the API call, and one can save the events. But there are drawbacks here too. What if you load is high, and you have actually 100 start strategy requested events saved before you have just done 80 of the actually API call? So these two can then get out of sync. Of course, you can place them in sequence again, and then you will not get this. And I think that is a good option, but it adds some latency, so we haven't chosen it due to that, but it's really a good option to look into. And in one of these, we have struggled a bit. And start algorithm, and that was because it was the first real dual write. And we were discussing in the team, and we said, let's see, we do only the API call, so we avoid this dual write because that is scary. And then someone in the team said, yeah, that's okay, but we can save the event. We doesn't need to throw the error if it fails. And then we in IT can have this event. And we actually did that. I don't understand why, but we actually did that, and we agree we shouldn't use this event. It should just be there and be helpful when it was there. And of course, that isn't a great thing to do, because these agreements, you tend to forget them. And some refactoring later, we got an issue that we believe was related to this in development, where we had scaled down our database. And we actually had started throwing those errors, because someone has done a refactor and see, oh, they are not throwing here. We thought we should do that, of course. So then we were thinking, OK, we will do both. But then you have the rule that if it is a dual write, make sure that step one is idempotent. And if you have an idempotent API, that's a good thing to have, because you can call it multiple times. But the third-party service we are using, they don't provide us with that. So we actually ended up swapping those two. So we first save the event, and then we do the API. And I feel that's the best we can do, but it's still not 100% safe. Because what if they actually started this algo? This algo is handling money, so it has to be right. And it didn't manage to tell us that it actually was started, like the two-genre problem, if anyone has heard about that. So we know we are not completely home safe yet, so we are working with a mindset of self-healing when building our application. We know that issues will happen, and on the places where we know we haven't handled the dual write completely because we are not able to, we add this additional layer of safety. It can be triggered by a timer or an event, and we actually check on the external platform and in our solution and see, OK, are we in sync? And if not, we do take corrective action. We do not send any mails or issues to IT. We let the application handle it, and that has helped us a lot. OK, I don't know if anyone has seen it, but when I've been talking now, I think I've been talking about an anti-pattern, because what is an internal event in one of our bonded contexts is actually an external event in the other. And the correct to do this is to have an outside event or an integration event, so you don't kind of show your internals. So don't go home and do as we do, at least not say I told you to. But for us, actually, we are one small team, and we have both those bonded contexts. So we see with skipping to having those reactors, that extra layer, we think to skipping this integration event, look here, we get a really common pattern for communication between the aggregate inside a bonded context and between our bonded contexts, so we get a bit less of complexity. But I wouldn't have done it if it was another team that owned the other bonded context. And reactors also prove a lot of flexibility, and that is something that has saved us more than once. Because you can have this one event and a lot of reactors listen to it, or a stream of event and scale out because you get the event. And Cosmos DB that we use is really good here, so it guarantees that we get in correct sequence the events of the aggregate to the same process. So I think reactors help us with distributed solution, and it's really good for building this modular solution. And it is the cool building blocks. But we should talk about read models too, because I like them too. But I like everything with event sourcing, but you have probably figured out that by now. And one thing I like about the read models is that we can do this, have them in memory, because the read models is just a projecting of the event. And if you, every time you restart your application, you start from the beginning, you can have them in memory. And then it's really fast when the client asks for the information, because it's already there. And in addition, I find that on the right side, the functionality, the users tend to know more what they need. But for the read models, when you show them some information, they suddenly understand what information they want to see. And that's a bit different. And it's easier to do this iteration when you have everything in memory. And we have in memory read models in production, but we have also places where we started with in-memory read models. And then when the stream got too long and it was too trouble to always build them up from start, we have started to save them. But the good thing is, of course, if the schema changes, you can always just change that, and even if you save it, you can delete those read models and build them up from scratch. So read models is a good building block. But also here we need to think about error handling and duplicate handling, and here we actually have different strategy than we have for the reactors. For instance, for duplicate handling, we just have a list of the domain events that is already projected, and that can be saved in one transaction together if we save the remodel, or we can have it in memory. So here we have a more technical approach to actually identify those duplicates. And for the error handling, we log the error and we go on. And that is a completely different strategy. But the reason for it is that if we get a null pointer exception here, we can still just skip that event. And we might get some data issues, but we are not afraid to get into that corner because we can fix the issues and build up the read model from scratch again. And then that data issue will be fixed. And of course, these read models, when we have an error, we log it, we get it up in our monitors, and we have internal users, so we can actually tell them, in this area now we have an issue. So don't trust your data there. But that's better than let all the data be stuck on waiting for it to actually show up to the users. And then we have read models. Our read models are eventually consistent, as you will expect. And sometimes when I read on the big internet, I feel that it's so a big deal that these read models are eventually consistent. And I'm not sure if I agree with that it's so big deal. And the reason for that is that when I worked on an old solution, we had this big, huge monolith with a giant of a database with 2 phase commit and being the best in class, and it was really strong, consistent all the way. And I had the pressure to have a walkthrough with a lot of the users to see how they use the solution. And one of them told me something that has stuck to my mind. This was a solution with a lot of windows. So she said, if someone changed the information in this window, I can just refresh and I can see it. But in this window, if someone changed the information, I need to remember to close it and open it again, and then I can see the changes. And then she had a third window where she said, if someone changed the information here, I actually have to close the application down and restart it again to see this information. So yeah, the database was strong, consistent, but did that actually help our users? Might be our eventual consistent user interface are better because our read models, they know when they are updated. That is just when they get a projection in. And they can say, hello, I'm updated, and we try to push it out to the client, and then the user gets that information right away. A bit delayed, yes, but they do not need to do any refresh and know when to do what kind of refresh. So I think read models are great. Okay, of course we have this how to correct data issues in our event source application. And here I want to start, and here I think about data issues because of a bug, and not because of the user has done something he shouldn't. Because if the user starts a strategy, it needs to have a compensating action, stopping that strategy, and that kind of fixes it. But if we have a bug, we can get to data issues. And I want to start with a story, because I was actually at a hotel and was listening to an elderly couple, talking to some friends, it seems, and they said, next week we are going to have a diamond wedding. And our children have started to ask us, what is the secret? How do you stay married for 30 years? And the wife said, I had told them the secret. It is to have a very short memory. And then it struck me, that is the strategy that we had done for fixing mistake in our SQL application for years. We run a script and we have a vague recollection, there is a log somewhere, but there's no real trace in our solution. And this short memory strategy, that is also something we can do for our event source application. We have in Cosmos DB are something really attempted to just pick the one event and fix it, but that we can't do because it loses its sequence in the sequence of the streams. So sad face don't do that. But we can migrate the event, meaning that we read up the first event in the stream and we do any changes if needed and save it to a new event store, and you do that for all the stream. And we have done this once when it was a typo in the interface that has come all the way down to our domain event, and we were like, it isn't important for us to remember, really remember that this typo has happened. So we did the migration. So back to the real life. I guess this short strategy, short memory strategy will help in a lot of situations, but maybe not in all. What if you go to Las Vegas, you get married, and the next day you wake up and you regret it so much? I guess you can try the short memory strategy here too and just forget about it. But then, if you 5 years later meet the man or the woman in your life, and there it is, this irritating invariant rule that you can't get around. It says you're not allowed to get married to 2 persons at a given time. I guess you should have done some compensating action that would lead to some compensating events instead, and the marriage could be cancelled. And that is the thing we really like to do if we have data issues, because then we really get a trace as a core of our solution. And once we actually put some new functionality in the screen of our users, we have internal users, as I said, so they could do something there, and we got these compensating events, and we have the trace, and we knew that those events apply to all the aggregate rules. Yeah, but this migration of domain events, that we do also in a very happy case. That's when we have understood something new. We have understood something about our domain model, and we want to refactor down to that better insight. And when we do this, since we have this business concept, it's my DDD heart again, that said that we actually have one-to-one with the domain concept in the code and how we save our domain event, we need to do the migration. And our strategy up to now has been to try to do it often, because we are really afraid that we stop doing this refactoring because we want to avoid doing the migrations. But we have been talking that maybe we should have piled up some mapping there, just not to go away from having the domain concept in the domain event, but just so you can have 1-2 small changes before you actually do the migration. But we are allowed to have downtime in our solution, so this is actually how we handle the schemas are changing for a domain event. There is a great talk out there by Greg Young that a whole team was sitting there listening to that one, and we ended on this strategy, but I just want you to know there is a lot of alternative strategies for how to handle this. Yeah. And when it comes to extend the solution, I think event sourcing is really helpful here too. For us, when we had done this digital strategy for the one business area, and we should for the other. Well, for the strategy aggregate, we only needed to add some new domain events for that aggregate. But for the business area and all the business rules, for the new business area, we put a new aggregate. And it's just to have these building blocks that makes it easier, at least I think, to actually extend your application instead of always update it. So it's these building blocks again that helps us. So that's what we do when we are taking a new area. We sit down and we think about this. Where do we need, is there someplace we actually need to update? And if not, where should we extend this application, and with what building blocks? And to see that, we need to see the big picture, and we don't do orchestration or any of those stuff, so it is a bit hard to see the big picture. And we actually do use the diagrams from our event storming on the design level a lot related to this. And you can say, that's documentation. That will get outdated. And yeah, it does. It gets outdated, but it's really easy to extract from the code. So we make sure that it's updated before we take those discussions. And one day, I hope someone else, but if not, I need to do it, write something so we can generate this event storming diagram based on what is really in our application. But having these building blocks, that is how we get a good overview of the complete application. And that is the starting point when we need to extend it. So I think event sourcing, that is a complex arrangement. At least it is if I compare it with an old solution I have been working with, where it's no distributed solution, it's just one monolith. And I don't think there is a way around it. But it has to be a complex arrangement of simple part. And that it was something that Sebastian von Conrad said in his talk, and that I really have been thinking about a lot. Because if not, then you get a complex arrangement of complex part. And that is probably on the road to some place you don't want to be, and probably you end up with a distributed monolith. And I want to go back to the building blocks I started this talk with, because I think the clue, it is here. The clue is to always think about this really simple pattern for those building blocks. If you, for instance, see on the read models, the read models have only one event and an initial read model state. So if you get you in a situation where you have, this event, and before it was that event, and before it was that one and that one. If you get those complex rules, you're probably in the wrong place, because you should be able to do it just by using these patterns. That's the mindset we have anyway. And then we could get an event source solution that we want and believe that we can make it stay as an arrangement of simple part. And maybe that will make our solution easier, that it can grow for years and years without being so hard to manage. And it's easier also if you should take out some functionality from your solution. So a complex arrangement, but a simple, fun parts. That's the recipe of a good event source business application. So I'm approaching the end here now, but I want to end with some comments related to digitalization and event sourcing. Because the truth is, especially in the application I'm working with now, I'm like, how should I solve this if I haven't done event sourcing? And I think that is a sign that we have a problem to solve that is a good fit for an event source solution. Because event sourcing isn't the solution for everything. It's not like we have the pattern and now we need to find the problem. But for the problem we are solving just now, I think it is such a good fit that I sometimes don't know how I should solve it if I haven't had my event sourcing toolbox. And I think that in my company, where we want to do a lot of automation, these reactors, that's the building block from heaven. It takes care of all this. Whenever this happens, that should happen. And then we have the domain event, and we want to be data-driven. And what our domain event helps us with is that we can put all the details inside the domain event without making the rest of the application too complex. So it helps us to answer the tomorrow's question. And we in Equinor, we want digitalization, we want to be data-driven, but just as important is it to empower our users. It's so important that the users are the ones that really understand the automation we have and really have the view on it. So we need to empower them. And here, the read model are a very, very good fit. So by that, my personal bet is that I will continue living my work-life dream, building this event source business application, just because I think a lot of the initiative from my company will be a good fit for this kind of way of building solution. And by that, I want to thank you all for coming here and listening, and I hope you have a great rest of the day.